Hello dear students, welcome to this third lecture of chapter liquids, which is about hydrogen bonding. Previously I have explained dipole-dipole interaction and the introduction of liquids, whose link have been given in the description box, you may check. Okay, so first of all, let's just have a look on this molecule. This is a water molecule. H2O is it, and it's creating some hydrogen bonding with other one. Okay, we will discuss it, but before that, come to the table of content. Table of content that what I'm going to explain is about the condition of the hydrogen bonding, effect, example, strength of hydrogen bond, as well as the properties. So let's just start. What is hydrogen bonding? Hydrogen bonding refers to the formation of hydrogen bond, which are special class of attractive intermolecular forces that arise due to the dipole-dipole interaction between hydrogen atom that is bonded to highly electronegative atom and the other highly electronegative atom while lies in the vicinity of hydrogen atom. So hydrogen bonding exists in the molecule which is having hydrogen bonded with it, like water molecule has hydrogen bonded with oxygen. Then it will create some association with other molecule of water through the dipole interaction, like positive sign or the positive side of water will attract the negative part of other molecule. So this thing is a little bit similar to the dipole-dipole movement or dipole-dipole interactions that I discussed previously. So it is same kind of. However, here the vitality or the necessity is that hydrogen must be present. In those dipole-dipole interaction, that was not restricted to hydrogen only. Here hydrogen bonding is a dipole-dipole interaction which is restricted to the compounds having hydrogen. Okay, so water, H2O, HF, NH3, these all contain hydrogen and they create an association called hydrogen bonding. Okay, you will learn one by one these examples. Hydrogen is covalently bonded to more electronegative oxygen atom. Therefore hydrogen bonding arises in the water molecule due to the dipole-dipole interaction between hydrogen atom of one water molecule and oxygen atom of other water molecule. I have already explained you, right, that negative part of water molecule is creating an association with the positive end of other molecule, hydrogen. Okay, so it is a positive negative partial negative interaction in which positive is always hydrogen and negative part could be any electronegative atom like fluorine, nitrogen and oxygen. Okay, what are the conditions for hydrogen bonding? There are some conditions for the hydrogen bonding. Number one is the molecule must contain electronegative atom linked to hydrogen. Okay, first thing is that hydrogen must be present in the molecule. Second is that hydrogen must be bonded to some electronegative atom, and that electronegative atom will be the one which is having high electronegativity value. Greater the electronegativity, more will be the polarization and stronger will be the hydrogen bonding. Okay, so just focus on my words which I am telling you. Number second is the size of electronegative atom should be small. The bigger elements are usually not as much electronegative. Smaller elements are really highly electronegative. So this is the second situation, that the electronegative atom which is bonded should be small. Smaller the size, greater will be the electrostatic attraction. As I told you that hydrogen bonding is a dipole-dipole interaction, and dipole-dipole interaction is also electrostatic in nature. So hydrogen is also electrostatic attraction, right? Okay. Till date or till this moment I have told you that what is hydrogen bonding, how it is created, and what are the conditions of hydrogen bonding. Now coming toward why do compound having hydrogen bonding have high melting and boiling point. You know that water boil at what temperature? At at 100 degrees centigrade. Okay, so why it melts or boils at 100 degrees centigrade? Because of the hydrogen bonding. If hydrogen bonding wasn't present in the water, then it could boil it easily about at 55 degrees centigrade. So the hydrogen bonding just strengthened the bond. The compound having hydrogen bonding show abnormally high melting and boiling point. High melting and boiling point of compound containing hydrogen bond is due to the fact that extra energy is needed to break. Look here. If it was solitary, like it was alone H2O, then we would have to break that oxygen hydrogen bond. That oxygen hydrogen bond and the product would be melted. Okay, but now you have to destroy this association as well, this hydrogen bonding, which is another or an extra association. So that's why we need more energy to break the molecule or to split those molecules. That's why the melting point and the boiling point rise, and they are very high. The unusually high boiling point of HF among the halogen acid is due to the existence of hydrogen bonding. In all the HX or halogen halide acids, the maximum boiling point was attributed to HF because of the hydrogen bonding. Water is also a liquid, however, H2S, H2SE, H2TE, hydrogen telluride are all gases at ordinary temperature. But water is liquid. Why? Because water has hydrogen bonding, but H2S, H2SE, H2TE do not have hydrogen bonding. This is very important conceptual question that has been usually asked in competitive exams, that why water is liquid, while other are not. Ammonia, I also told you that it has high boiling point, but pH 3 do not have, because pH 3 is not able to make hydrogen bonding. Ethanol is also having a high boiling point. All the alcoholic functional groups are having high boiling point, usually the smaller ones, because they are having the association like called hydrogen bonding. Example of hydrogen bonding, I told you HF. Look here, one molecule of HF is creating hydrogen association or hydrogen bonding with other molecules negative part, fluorine. Okay, so this zigzag kind of attraction or association usually built up. Hydrogen bonding in water I have already explained you in this picture. Look here, this is the best example of water molecule that could explain the hydrogen bonding. Okay, hydrogen bonding in water, here it is also given. Hydrogen bonding in ammonia, in which the nitrogen of one molecule is attracting or creating a hydrogen bonding with the hydrogen of other molecule. Okay, hydrogen bonding in alcohols and carboxylic acid. This is also very important because they both have high boiling point because of this hydrogen bonding association. If I talk about the properties of hydrogen bonding, then hydrogen bonding has numerous effects or numerous properties. Number one is solubility. Low alcohols are soluble in water. Low alcohols mean that are very small in size, that do not contain much carbon. Okay, so these are lower alcohols like ethanol, propanol, butanol. These three are lower alcohols. They are soluble in water because they form some stronger hydrogen bonding with the other hydrogen, oxygen of alcohol and water. Second is volatility. As the compound involving hydrogen bonding have higher boiling point, so they are less volatile. Volatility and boiling point are vice versa or inversely proportional to each other. If any compound is having higher boiling point, then definitely it will be less volatile. And if anyone is saying this is very well volatile and this evaporates, then you should realize that that compound is having less boiling point. That's why this is volatile. So the compound having hydrogen bonding are very less volatile and have high boiling point. Viscosity and surface tension. The compounds that are have hydrogen bonding, their flow become comparatively difficult because they have stronger bonding, hydrogen bonding, so which cause the high viscosity and high surface tension. Lower density of ice than water. Water has very compact structure of hydrogen bonding. In that, cage-like structure is produced, so that's why ice float on the water. As a matter of fact, each water molecule is linked tetrahedral to 4 water molecule. In the ice form, when you just cool down or freeze the water, then the molecule will be linked to each other in a tetrahedral form, and they are more closely packed not as much closely packed as they are in the liquid state. They are a little bit far away. As a result, they are having less density, and that will just float over the any liquid upon which you will put. This cage like structure, this cage like, there is a missing cage like structure, collapses and the water molecule comes closer to each other. Thus, for the same mass of the water, volume decreases and density increases.